Implement stack using linked list. We have to implement a stack using linked list. Here we have given operations like push and pop. We have to implement these operations into a linked list and implement the stack. Stack is based on principle last in, first out. The element which goes in the stack last will come first. Let's see. This is input. We have to push 2. Currently we have no node. What is linked list? Linked list is a linear data structure which contains nodes. All nodes are connected to each other. The node contains the address of the next node. So suppose we are doing first operation push 2. We have no node. So first we have to create a node named 2. So this is our node. Suppose this is our node 2. Now again push 3. Here we are pushing in the left of the this node. So we are pushing here. And this is linked list. So 3 will connect to 2. Now operation is pop. Pop means which operation come out, which element will come out first, which goes last. So in this linked list, which element goes last? This 3. It is go in the last. So we will pop 3 and 3 will come as output. Now we have to push 4. So where we will push? Here 4, and 4 will point to 2. Now we have to pop. So which element will be popped? The element which comes last in the list. So which element comes last in the list? This 4. So 4 will be popped here. Now see next example. This. Initially we have no node in our linked list. So how can we pop an element? There is no node in the linked list. So we will pop -1. Means no element in the linked list. Now we will push 4. We have no node, so we will have to create a node in the linked list and then push the data 4 into it. Now push 5. So we will push in the beginning of 4 5, and 5 will point to 4 because we have to implement a stack using linked list. Now pop. So which one will be pop? Which comes in the last. So which come last? 5. So 5 will be pop, and here we get the answer. So in linked list, the first node is always called as head. And if we want to access 4, how can we access it? By head, not next. Next is a pointer which points to the address of next element. So head is 5. So 5 will point to 4, means head dot next is 4. Now let's see how we will insert the data, insert the node. So if there is no node, if self dot head is none, so we have to make new node. If there is initially no node in the linked list, so we have to make a new node. If there is already exist a node, suppose 5 is inserted in the 2 linked list and 4 is already exists, so we will insert that 5 in the beginning. So 5 will point to this 4. 5 will point to this 4 and this 5 become heads. Suppose if we insert a more node, so 6 will point to 5 and still 6 is in the front position, so it will become head. So any element which comes in the first becomes the head. Okay, if we want to delete an element, if we want to pop an element, then we will first have to check that if linked list is empty or not. How can we check that linked list is empty? If the head is what? First node is null. None means there is no first node, nothing. It means that head is none, so we will written -1. And if always, if we have to pop the data, then we will always pop the first one. In this case we pop 5, it was first element. So how can we access the first element? By writing head dot data. And if we delete then self this becomes self dot head, means head is shifted to next node. Now see the code. First of all, in the case of push, we always have to create a new node, means we have to put the data into a node. How can we create a node? By writing this node. Here node is already defined, so we will create the node. Now what we will do, if there is no element, linked list is empty, then we have to make this new node self.head. So first we check self.head is none, means linked list is empty. If linked list is empty, then self.head means first node will become new node. Now else if it is not so, then what will be happen? New node dot next equals to self dot head. Means suppose there is 4 already and we want to push 5 here, so 5 will be new node, and earlier 4 will be head. This was head na, before inserting 5, so new node next is equals to head. And now after pushing 5, 5 will become head, so self dot head become new node. Now see the pop function. In this, if linked list is empty, we have to return -1. How we check that linked list is empty? If self dot head means beginning element is none, means nothing in starting, then return -1. If there are elements, then we have to always access the first element, and first element is always head, so we will get head dot data. I am creating a variable popped in which we store the first element, which is self dot head dot data. Now we have to delete that, so we have to shift self dot head to the next element. Now return the popped data. Here we are getting error that my stack object has no attribute head. So we have to declare that. How can be declared? By using init method. Initially self dot head is none.